So imagine waking up every morning and every single movement you make from when you get out of bed and all throughout the day has to be assisted. Your mind is sharp, but your body's not. So you are pretty much trapped inside your body. That is the daily life of an ALS patient. My name is Luke Redito. We are with Teachers in Space and Space Frontier Organization.
Hello everyone, my name is Harshit Sani, this is Sanju Vardhan, and this is Robert Emerson. And we are 4 principal researchers from a team of 15 people from West Shore Junior Senior High School. Now, the title of our project is a study of how microgravity affects the enzymes and amyotrophic lateral sclerosis using the model of Papain and Gelatin. Now, some basics of ALS. In ALS, glutamate is found in the motor neurons in the synapse, and what happens in ALS is that the glutamate builds up to toxic levels. When this happens, the motor neurons start to die out. Now, with motor neurons, they don't regenerate, so once they die out, they're gone. This results in muscles dying out since there's no control over them by the patient. And what happens is that when they lose this muscle movement, eventually they lose control of their diaphragm as well. And when that happens, the patient dies. Researchers have always wondered exactly what causes ALS, and there's no specific cause for it. So we decided that we really wanted to investigate this. One of our main causes for this was because our teacher, Jason Whitworth, was diagnosed with ALS at the age of 40 in 2011. Now, when this happened, we were heartbroken. We didn't really understand what ALS was and how it affected him and what it was going to do. And when the opportunity for this project came up, we decided that we were going to try to do something to help Mr. Whitworth. Now, this experiment will serve as a model for the reaction between glutamate and glutamate dehydrogenase in ALS patients.
Our mission hasn't gone to space up yet, so all the trials or the data that we've collected so far was majorly to determine the amounts of papain enzyme and ascorbic acid or vitamin C, which is a fixative that we decided to use to terminate the reaction between papain and gelatin. So we did standard protein assays and a spectrophotometer to get our data, and it showed that the 0.2 grams of papain and 0.2 grams of ascorbic acid was the most appropriate amounts to use for the reaction because they produced the most viable results from the assay and the most consistent results. So again, for reaction is going to be occurring in the fluid mixing enclosure or an FME provided by Nanoracks, and the main volume is containing 5 milliliters of gelatin, and the short ampule A is containing 0.2 grams of papain, and the short ampule B is containing 0.2 grams of ascorbic acid. Our procedures is going to be the same as the International Space Station and on Earth for the ground treatment. So on day 1, the short ampule will be cracked, and we be going in the mixing with the gelatin, the papain enzyme, to initiate the reaction. And then 2 days later, the ampule B will be cracked, and so the vitamin C or ascorbic acid will be mixing in with the reaction mixture and terminating the reaction. And we'll bring the FME back down to the ground and do our analysis. So the data here seen on the slide is kind of the ground trials that we've been conducting with practice FMEs and other vials, and we did them just to confirm once more if the 0.2 grams of papain and vitamin C were the appropriate amounts to use.
The way that we take and test how much was absorbed is we add a Bure protein assay that detects any amount of protein in the FME that we'll get from the ISS and that we run on Earth. And this Bure will either turn our sample purple, which means that there's protein in it, or it'll turn it pink, which means that there's polypeptide. After we get our color change, then we'll stick it in our spectrophotometer, and then we will compare our 2 samples. And so the efficiency of the enzymes are going to be measured by the amount of protein remaining in the sample after the reaction has taken place.
So in addition to creating this gelatin and papain model, we also wanted to get involved with our local ALS community. So our mission was to raise awareness for the disease, and by doing that, we wanted to raise funds for the ALS community by selling mission patches. T-shirts and bracelets. And we also participated in different events such as Jason's Run, which is a 5K run that we were able to raise $25,000 with, as well as Walk to Defeat ALS, which we were also able to raise $12,750 as well. In addition to raising money for the local ALS community, we wanted to get involved and really put a face to a disease. So what we did, we attended different monthly ALS group meetings, which is a kind of a support group. And it was really moving to really be able to see people that, this disease is truly affecting. And we wanted to do all that we could to help, make a difference in their lives. So we were able to find the different materials necessary that they needed, such as vials of life, which are electronic bracelets that have stored medical history. And we also are now starting a project with dealing with equipment loan costs for people that are affected with ALS. Also, we wanted to say a huge, huge thank you to everybody that helped make this project possible and assisting us in helping make a difference. Thank you.
Does anybody have any questions for the team from the Teachers in Space community?
Hi, Rich Barnhart from East Lyme. On your second or third slide, you had two different tables of absorbances and Papain and gelatin concentrations, or ascorbic concentrations. What were the difference in the two tables?
The first table is kind of comparing different combinations of papain enzyme and vitamin C. And that first table was kind of seeing what amount of vitamin C to be used. And once we decided that 0.2 grams seems to be the most consistent and viable from our assay, we then paired that same amount of vitamin C to different papain enzymes. And then we could see the same combination of 0.2 grams of papain ascorbic acid were producing the consistent in not only the color from the protein assay, but also absorbance values.
Thank you.
Hi, I'm Joel Jackal from Teachers in Space. I teach in northern New York City suburbs. Great presentation. Thank you very much for representing us so well.
Thank you.
Question I have, you have a connection with the teacher. I have some friends who are suffering from muscular dystrophy. Different disease. The end result, unfortunately, is the same, especially the diaphragm and involuntary muscles no longer working. Could some of this research that you did be applied to muscular dystrophy research?
We believe that through this research, any disease in which an enzyme is not functioning as well as it should be and breaking down the substrate that it is involved with, we believe that this research could help out anyone with that kind of disease. Because as commercial space flight is, as we're getting closer to it by every second, our hope is that someday it will be economically feasible for people with such diseases, if our experiment turns out well, that they could go into microgravity situations, and then perhaps that will help prolong their lives or lessen their symptoms. That's our hope.
Thank you very much.
Thank you.
Well, it's really wonderful that this experiment is bringing awareness to ALS, and we're very proud of what you're doing. So really great job. Let's thank the team from the Teachers in Space community.